The siege of Masada stands as a monumental chapter in history, illustrating the fierce conflict between Roman forces and Jewish rebels during the 1st century. This remarkable event unfolded against the backdrop of the Jewish-Roman wars, where the Jewish people sought to resist Roman oppression. Masada, a formidable fortress perched atop a plateau, became the last stronghold for the Jewish defenders led by Eleazar ben Yair. The Romans, under the command of Flavius Silva, faced the daunting task of breaching this seemingly impregnable stronghold. The engineering prowess of the Romans was put to the test as they devised innovative solutions to overcome the natural defenses of Masada. This introduction sets the stage for a story of resilience, ingenuity, and the relentless pursuit of power amidst a turbulent historical landscape. Masada stands as a breathtaking fortress perched atop a plateau in the Judean desert. Its steep cliffs rise dramatically, creating an imposing natural barrier that seems to defy any attempt at invasion. Designed by Herod the Great, this stronghold was crafted to be a refuge, equipped with lavish palaces, storerooms, and intricate water systems, showcasing advanced engineering for its time. The walls of Masada, fortified and towering, provide a sense of security to those within, making it appear nearly impregnable. The surrounding landscape, arid and rugged, only enhances the fortress's isolation, emphasizing its strategic significance. As one gazes upon Masada, it becomes clear why this site was chosen as a last bastion of resistance against Roman forces, embodying both beauty and strength in its formidable architecture. Flavius Silva, the Roman commander, faced an arduous task in capturing the formidable fortress of Masada. Tasked with subduing the Jewish rebels, Silva encountered significant strategic disadvantages. The Jewish defenders, well supplied and resolute, had fortified their position atop the steep cliffs, making direct assaults nearly impossible. The Romans, despite their superior numbers and training, struggled against the natural defenses of the fortress. The defenders had access to ample provisions and water, which bolstered their morale and determination. Silva's forces, on the other hand, were reliant on traditional siege tactics that proved ineffective against such a well-prepared enemy. The challenge ahead was daunting, requiring not only military might, but also innovative engineering solutions to breach the seemingly impregnable stronghold of Masada. Masada's geography posed significant challenges for the Roman forces attempting to capture the fortress. Perched atop a plateau, the fortress measured approximately 1,400 meters long and 400 meters wide, creating a formidable stronghold. The steep cliffs that surrounded Masada provided natural defenses, making traditional siege tactics nearly impossible. The sheer vertical drops deterred direct assaults, while the rocky terrain complicated the movement of siege equipment. Additionally, the fortress's strategic location allowed the Jewish defenders to maintain a well-stocked supply of food and water, further complicating the Romans' efforts. The combination of these geographical features rendered conventional warfare ineffective, forcing the Romans to devise innovative strategies to breach the stronghold. This unique landscape ultimately shaped the course of the conflict between the two opposing forces. In the year 66, the Roman 10th Legion, under the command of Flavius Silva, arrived at Masada, marking a pivotal moment in the conflict. This formidable force aimed to quell the Jewish rebellion led by Eleazar ben Yair, who was resolute in defending the stronghold. The Jewish rebels, motivated by their desire for freedom, were determined to resist the Roman advance. Eleazar's leadership inspired fierce loyalty among his followers, who viewed their struggle as a fight for survival against an overwhelming enemy. Despite the odds stacked against them, the defenders were well prepared, fortified by supplies and a strategic advantage provided by Masada's rugged terrain. This clash of wills set the stage for a dramatic confrontation that would unfold in the days to come. Faced with the daunting task of breaching the fortress of Masada, The Romans devised an innovative solution that would showcase their engineering prowess. The construction of a massive earthen ramp was not merely a practical response. It was an audacious undertaking that reflected the scale of the challenge they confronted. This monumental project required meticulous planning and immense resources, as the ramp needed to rise high enough to reach the fortress walls. The Romans, determined to overcome the steep cliffs and natural defenses, mobilized thousands of soldiers to transport earth and stones, creating a pathway that would ultimately lead to their success. This engineering feat not only demonstrated the Romans' ingenuity, but also their relentless pursuit of victory in the face of formidable obstacles. The Romans strategically chose the western side of Masada for constructing their massive earthen ramp. This location was advantageous due to the presence of a natural ridge that provided a solid foundation for their ambitious engineering project. The ridge not only facilitated the ramp's elevation, but also shielded the Roman workers from direct attacks by the Jewish defenders stationed above. By utilizing the ridge, the Romans minimized the amount of earth they needed to move, allowing for a more efficient construction process. This choice also offered a relatively unobstructed path to the fortress, enabling the Romans to position their siege equipment effectively. The combination of natural terrain and Roman ingenuity exemplified their determination to overcome the formidable defenses of Masada, setting the stage for a pivotal moment in this historic conflict. The construction of the ramp at Masada was a monumental endeavor, requiring an immense volume of materials and labor. The ramp measured approximately 600 feet in length and rose to a height of over 100 feet, creating a formidable incline. To achieve this, the Romans utilized around 100,000 cubic feet of earth and stone, meticulously transported from nearby sources. The sheer scale of this project necessitated the efforts of thousands of legionnaires who worked tirelessly day and night. Each load of materials was carefully calculated to ensure stability and durability. The Romans faced not only the physical challenge of moving such vast quantities, but also the relentless pressure from the Jewish defenders. This monumental effort showcased Roman engineering prowess and determination in the face of adversity. The Romans employed advanced engineering principles to ensure the stability of the massive earthen ramp at Masada. A deep understanding of soil mechanics played a crucial role in their design. By analyzing soil types and their load-bearing capacities, engineers could predict how the ramp would perform under pressure. Additionally, the Romans integrated sophisticated drainage systems into the ramp's design. These systems prevented water accumulation, which could weaken the structure and lead to potential failure. The careful placement of drainage channels allowed for effective water runoff, maintaining the ramp's integrity throughout the siege. This combination of soil mechanics and drainage ensured that the ramp could support heavy siege equipment and thousands of soldiers, showcasing the Romans' remarkable ability to blend practicality with innovative engineering solutions. The construction of the earthen ramp at Masada was a monumental task that required the organization of thousands of legionnaires into specialized work crews. Each crew focused on specific aspects of the ramp's construction, ensuring efficiency and effectiveness. The Romans faced significant logistical challenges, including the transportation of vast quantities of materials such as earth and stone. The coordination among crews was essential, as they had to work in unison while managing limited resources. Additionally, the harsh desert environment posed difficulties, demanding careful planning to maintain morale and productivity. The sheer scale of the operation showcased Roman engineering prowess as they adapted to the challenges of the terrain and the urgency of the siege. This organization ultimately played a crucial role in the success of the construction effort. As the Romans undertook the monumental task of building the earthen ramp at Masada, they faced constant threats from the determined Jewish defenders. To protect their workers, the Romans implemented a series of defensive measures. First, they established a perimeter of watchtowers manned by vigilant sentries who could alert the laborers of any impending attacks. Additionally, they utilized a mobile shield wall, allowing workers to quickly take cover during skirmishes. The Romans also employed a strategy of rotating labor crews to minimize exposure to danger, ensuring that fresh teams could work while others rested in safety. Furthermore, they reinforced their camps with fortifications, providing a secure base from which to launch counterattacks. These tactical decisions were crucial in maintaining momentum during the challenging construction phase. The construction of the ramp at Masada demanded extraordinary precision to ensure it met the necessary specifications for the siege equipment. Roman engineers meticulously calculated the ramp's angle and width, critical for the safe transport of heavy machinery and troops. They understood that even minor deviations could compromise the entire operation, risking both the lives of legionnaires and the success of the siege. To achieve this, they employed advanced surveying techniques, ensuring that every layer of earth was placed with accuracy. The ramp needed to withstand the weight of siege towers and battering rams, which required a robust foundation. This attention to detail not only exemplified Roman engineering prowess, but also highlighted the importance of precision in military operations, where the stakes were incredibly high, and failure was not an option. To transport heavy siege equipment up the ramp, the Romans employed a combination of ramps, pulleys, and meticulous coordination of manpower. The use of wooden ramps allowed for a gradual ascent, making it easier for teams of soldiers to maneuver large siege engines like battering rams and catapults. Pulleys were strategically placed to assist in lifting these massive structures, reducing the physical strain on the workers. Coordination was key. Thousands of legionnaires were organized into teams, each with specific roles in the transportation process. This included hauling, lifting, and securing the equipment as it moved up the ramp. The synchronization of effort ensured that the siege engines were efficiently positioned for the impending assault, showcasing Roman ingenuity and discipline in the face of daunting challenges. As the Jewish defenders of Masada observed the relentless construction of the Roman ramp, a profound psychological shift began to take hold. Each day, the sight of the ramp rising against the stark landscape served as a grim reminder of their precarious situation. The sheer scale of the Roman effort instilled a sense of inevitability regarding their defeat. The defenders, initially fueled by hope and determination, began to feel the weight of despair. They witnessed the Romans' unwavering commitment, which eroded their morale and sense of agency. This psychological burden was compounded by the isolation of their fortress, amplifying feelings of helplessness. The ramp's construction symbolized not just a physical threat, but a mental one, as it transformed their struggle from a battle of resistance into a looming tragedy. As the Roman forces prepared for the final assault on Masada, they faced an unexpected challenge: a secondary wall erected by the Jewish defenders. This wall was a desperate attempt to strengthen their defenses against the advancing Romans. Flavius Silva, the Roman commander, quickly adapted his strategy. Recognizing the wall's vulnerability, he ordered his troops to use fire as a weapon. Torches and incendiary materials were employed to set the wall ablaze, creating chaos among the defenders. The flames consumed the wooden structures, weakening the wall's integrity. As smoke filled the air, the Romans launched their assault, exploiting the confusion. With the secondary wall compromised, the Romans pressed forward, determined to claim victory. The combination of strategy and fire ultimately led to the fall of Masada. The ramp at Masada stands as a monumental testament to Roman engineering ingenuity. Constructed under immense pressure, it showcases the ability to adapt and innovate in the face of daunting challenges. Modern engineers can draw valuable lessons from this ancient achievement, particularly in project management and resource allocation. The meticulous planning and execution involved in the ramp's construction highlight the importance of teamwork and specialized skills. Additionally, the ramp serves as an early example of utilizing natural landscapes to enhance engineering projects, emphasizing sustainability. Understanding the historical context of such feats can inspire contemporary engineers to think creatively and embrace challenges. Ultimately, the legacy of the Masada ramp transcends time, reminding us that great engineering is often born from necessity and determination.